Hello. Today we're going to be talking about multiplying polynomials. So you can see an example here. These are both binomials. They only have two terms each. Okay, so go ahead and copy this into your notes. When we're multiplying binomials, we use the FOIL method, which means we multiply the first, the outer, the inner, and the last. This actually stands for the terms that you're multiplying. So I'm going to go ahead and just do this and show you what that means. So when we're multiplying the first terms, that means we're multiplying the first term and the first term. So this times this. Then we need to multiply the outer terms, so this times this. The inner terms, meaning we multiply this times this, and the last terms, meaning that we multiply this last term times this last term. So we can see here that each term is multiplying. So technically, we're distributing this term into every single term in this expression, and you'll see a better example of that later when we multiply bigger polynomials. So let's just go ahead and finish our FOIL. If I'm multiplying the first terms, I have 2x times x plus, we do our outer terms, x times negative 4, our inner terms, plus 3 times 2x, and finally our last terms, 3 times negative 4. So when we simplify that, we have 2 times x, which becomes 2x squared. We simplify negative 4 times x. And from there, we see that we can combine like terms. Negative 4x and 6x can be combined. So when we rewrite this in its final form, we'll have 2x squared plus 2x minus 12. So I know that the book teaches the FOIL method. However, I'm going to show you another way that will apply when we multiply larger polynomials. And so this is another way that you can do it. So even though these are binomials, I have 4x squared plus 3x times x minus 5. What I need to think about is I'm actually distributing each one of these terms here and multiplying each of these terms into all of this. So what I'm going to choose to do is say that this term here will distribute and multiply this times this. The other term will also distribute and multiply every single term in this other expression. And this way is easier for me personally, so I'm fine if you choose to do it this way yourself. When I multiply that out, starting here with 4x squared times 1x, I'm going to end up with 4x to the third. Then I multiply 4x squared times negative 5, and I get negative 20x squared. Then I can move on to my pink terms and do 3x times x, remembering that this is positive. And from there, I can combine my like terms. So this is another valid way of doing multiplying polynomials. And I'll show you an example of why I like this better using larger polynomials. And this is where it's going to start getting fun. Here we have a much larger polynomial. And here the FOIL method doesn't work. Instead, we just have to remember that each one of these terms here must distribute and multiply every single term on the inside of this other polynomial here. So what that means is I'm going to start with this first term here, and this is going to have to multiply every single term, but so will this. Negative 3 will multiply every single thing on the inside of this parentheses as well. So this is going to be a pretty long problem. Let's go ahead and get started with our 2x times 4x squared. Remember, the coefficients multiply each other, and then the exponents of these variables add. So I have 8x to the fifth minus 4x to the third. So this is the blue, so I've multiplied the 2x times every single term on the inside here. Now I'm going to go to negative 3 and use that to multiply every single term on the inside of this expression here. So from there, I'll get negative 12x to the fourth plus 6x squared minus 21x plus 15, remembering that a negative times a negative is a positive. So from there, I'm going to combine my like terms, but I'm also going to rewrite it in standard form, in descending order of variable. So starting with 8x to the fifth, my next term is negative 12x to the fourth here. So from here, I have two terms to combine. I have 14x squared, and I have positive 6x squared. Then I have negative 10x, negative 21x. And now I've fully multiplied this polynomial. It looks gross, but it's really not that complicated.